This is section 3.8a, solving equations for a variable. In this section, you're going to have problems that are going to ask you to solve for a certain variable. In this example, we're being asked to solve for y. So you're going to have to write everything in terms of y, which means isolate the y and get all the other terms on the other side away from the y. In this case, the 3x is on the same side as the 4y. So I want to take that 3x and move it to the other side by subtracting 3x from both sides. 3x minus 3x is 0, or we can just say that 3x will cancel each other out. But then we also have to subtract the 3x from both sides. Now here's a potential problem. A lot of people look at 7 minus 3x and they say, well, that's 4x or something along those lines. You cannot combine 7 and 3x because they're not like terms. All you can do is just write it as 7 minus 3x. Now I still haven't gotten the y by itself. There's a negative 4 connected to it. The negative 4 is connected with multiplication. So we're going to do the inverse of multiplication, which is division. And we're going to divide both sides by negative 4 to keep the equations balanced. The negative 4's will cancel, leaving me with a y, which is exactly what I wanted. And on the right side, I have 7 minus 3x over negative 4. Now this is fine for a solution. There is a little trick that I'd like to show you. It's something that you'll want to get used to, especially as we move through the chapter. On the top here, I'm going to factor out a negative 1. Now when you factor negative 1's out, all that does is change signs. So this 7 is going to become a negative 7, and I'm going to put it in the back. You'll see why in a second. This negative 3x is going to become a positive 3x, and I'm going to put that in the front. I'm also going to factor a negative 1 out of the denominator. And what's left is a 4, because now if you notice the negative 1's will cancel, leaving me with a new expression, 3x minus 7 over a positive 4. Either one of these is acceptable as a solution. It's not a bad idea for you to start getting used to the idea of taking out negative 1's of expressions so you can simplify them or write them in different ways. In this case, the x term is first and it's positive. There are some things that we can do later on in the chapter if you're able to take out a negative 1. In this example, we're being told to solve for b. So the b is the variable we want to isolate. We want to move everything away from that. I'll start by moving this 12c. It's a positive 12c, so I can eliminate it with subtraction. And what I do to one side, I have to do to the other. So 5b is left on the left side. That's going to be a 0. And then 9 minus 12c, I cannot combine that because those are not like terms. Please be careful and don't write that as a negative 3 or a negative 3c. Now the b is almost alone, except the 5 is there, and to get rid of a 5 of multiplication, I'll divide both sides by 5. And so I'm left with b 9 minus 12c over 5. I'm going to leave that as my answer. I'm not going to factor out the negative 1 because you notice the denominator is positive. Factoring out the negative 1 really won't help me with anything, so we'll leave that right there as my solution. Notice the b is isolated and everything else is on the other side. This example is interesting because I'm being asked to solve for m, which means I want to isolate the m. But if you notice, there's m's that are on opposite sides of the equal sign. We've seen that a little bit before, but what we haven't seen is we have on the left a 2m and on the right an sm. That's going to be interesting. Before I can isolate the m, I have to first get them on the same side because this equal sign acts as a wall. So I'm going to take this sm and move it over. The only way I can do that is with subtraction, because I want to move the whole sm, not just the s. If I wanted to just move the s, I would use division. Then I have to subtract sm from the left. Well, the right side is fairly easy. The sm's are going to cancel off, leaving me with just the 5 and the equal sign. But on the right, since 2m and sm are not like terms, because this is two variables being multiplied and this is a coefficient in a variable, the only thing I can do is do 2m minus sm minus t. Now because I want to isolate the m, I can at least get the t away. Subtraction of a t can be undone with addition of a t. So 2m minus sm. And because 5 and t are not like terms, the best I can do is 5 plus t. So we don't have the m isolated, but at least we have all the m's on one side, and I can do something now to get the m's isolated. If you notice, these two terms both have an m in common. So what I can do is I can factor out a GCF. I can factor out a greatest common factor of m. I can take the m out of that. And if I do, what I'm left with is 2 minus s equals 5 plus t. And now I actually can isolate this m. Because the m is being multiplied by this binomial, I can get rid of multiplication by using division. So if I divide both sides by 2 minus s, I can now cancel off these two binomials, leaving me with just the m. So I have now successfully isolated the m. And on the right side, 5 plus t over 2 minus s. Here's another example of solving. In this case, I'm solving for x. I have x's that are on opposite sides, so I'd like to get them together. I'm going to do that by moving the xy. So I'm going to add xy to both sides. 7x plus xy, those are not like terms, so all I can do is put them next to each other. And then on the right, negative xy plus xy is 0, leaving me just a 4. I can then add the 2z in an effort to get all the x's on the same side. So 7x plus xy equals 4 plus 2z. Cannot combine those, like I said before, but they do have a common factor of an x, so I can factor that out as a GCF, leaving behind a 7 plus y. And now, since 7 plus y is being multiplied, I can eliminate it with division. So my x is isolated, and it equals 4 plus 2z over 7 plus y.